Hello viewers, welcome to our channel Career Prep. The study of permutation and combination is important for developing analytical and problem-solving skills and provides a foundation for advanced mathematical concepts in a variety of fields such as probability, statistics, and computer science. Permutation and combination forms an important portion in competitive exams like SSC, UPSC, railways, banking, etc. Since questions based on this topic are most frequently asked in competitive exams, it makes sense to understand the concept well. Permutations are of two types, linear and circular. In this video, we'll learn about the concept and formulae on the topic linear permutation. The concept, formulae, and questions on linear permutation are dealt with in this series of videos along with detailed explanations to make you understand the topic easily. Before we begin, please subscribe to our channel. Also press the bell icon to get notifications as soon as we post a new video. So let's start. What are permutations and combinations? Let's first understand the basic difference between permutations and combinations. A permutation is an arrangement of some or all of a number of objects in a definite order. Let's understand this definition with the help of an example. Let's suppose that you have three letters A, B, and C. The permutations that can be made by taking the letters A, B, and C two at a time are six. That is AB, BA, BC, CB, CA, and AC. So, if you take two letters at a time from the three letters A, B, and C, you will get six arrangements. Each of these arrangements presents a different arrangement of two letters. The order of the two letters matters since different orders give different arrangements. So as you can see in these arrangements, order of the two letters matters. So AB is different from BA. As you can see here, in this arrangement, A is in the first position, whereas in this arrangement, B is in the first position. So clearly, these two arrangements are different and the order of the two letters matters in permutation. Now, these six arrangements are called permutation of three objects taken two at a time. So in permutation means arrangement, and in permutation the order of the things matters. Now let's understand what is combination. A combination is the selection of some or all of a number of objects where the order of selection does not matter. Let's understand this definition with the help of an example. Let's suppose you have three letters A, B, and C. The selections that can be made by taking the letters A, B, and C two at a time are three. That is AB, BC, and CA. The order of the two letters does not matter since a group only refers to the selection of two letters at a time. So whether it is AB or BA, BC or CB, CA or AC does not matter in the formation of groups. So if you take two letters at a time from the letters A, B, and C, then the number of selections that can be made is 3. That is AB, BC, and CA. As you can see here, the order of the two letters do not matter in the combination because you are in combination you have to select two letters, and whether you select AB or BA from the three letters A, B and C, it is the same. Whether you select AB or BA, it is the same because you're selecting the same two letters. Similarly, whether you select BC or CB, it is the same because you're selecting the same two letters B and C. Likewise, whether um, Likewise, the arrangement CA and AC are the same because you are selecting the same two letters C and A. So in combination, the order of the letters does not matter. So in combination means selection, and the order of the selection does not matter. Hope you have understood the difference between permutation and combination. Permutation is nothing but arrangement and the order matters. Combination is selection and the order does not matter. Now, in problems on permutations and combinations, whenever you are asked to arrange some things, then you should know that it is a permutation problem. Whenever in the problem you are asked to select some things, then you should know that it is a combination problem. So, permutation is arrangement and order matters. Combination is selection where order does not matter. Now, in this video, we'll learn in detail about permutation. Let's now understand the kinds of permutations. There are two kinds of permutations, linear permutation and circular permutation. Let's understand the meaning of these two. Linear permutation. If the objects are arranged in a line, then the permutation is called linear permutation. It is simply written as permutation. Circular permutation. If the objects are arranged around a circle, then the permutation is called a circular permutation. In this video, we'll learn about linear permutation. Let's understand a few fundamental principles of permutation. Product rule and addition rule, which is very important while solving problems on permutation and combination. Now, first let's understand what is product rule. If an operation can be done in m different ways and a second operation can be done in n different ways, both the operations can be done in succession in mn ways. Now let's understand this rule with the help of an example. Suppose there are two ways of reaching the school from your house, and from the school there are three ways of reaching the swimming pool. Then the total number of ways of reaching the swimming pool from your house is 2 multiplied by 3, which is 6. Hope you have understood this. Let's suppose that there are two routes from your house to reach the school, and from the school there are three ways of reaching the swimming pool. Now supposing you take one route from your house to the school, then from the school to the swimming pool there will be three ways or three routes. Supposing you take another route from your house to the school, then from the school to the swimming pool again there will be three routes. So the total number of ways of reaching the swimming pool from your house is three ways if you take one route and three ways if you take another route. So the total number of ways is 2 multiplied by 3, which is 6. This is the product rule. Let's now understand the addition rule. If an operation can be done in m different ways or it can be done in n different ways, then both the operations can be done in succession in m plus n ways. Let's understand the addition rule with the help of an example. A woman has decided to shop at one store today, either in the north part of the city or the south part of the city. If she visits the north part of the city, she will shop at either a mall, a furniture store, or a jewelry store. So there are three ways she can shop if she visits the north part of the city. Supposing she visits the south part of the city, then she will shop at either a clothing store or a shoe store. So there are two ways for her to shop if she visits the south part of the city. Thus you can see here that there are 3 plus 2, that is 5 possible shops the woman could end up shopping at today. So if she visits the north part of the city, there are 3 possible shops the woman could shop at. And if she visits the south part of the city, there are 2 shops where she can shop. So totally there are 3 plus 2, that is 5 possible shops the woman could end up shopping at today. This is the addition rule. Remember that whenever you are solving a problem in permutation and combination, if you find the word and, it means multiplication. And if you find the word or, it means you have to do addition. So and means multiplication and or means addition when solving problems on permutation and combination. You will understand this later when you solve problems on the topic permutation and combinations. Another important concept you have to understand is factorial notation. Factorial is a mathematical operation denoted by this symbol. Factorial of a number is the product of all the positive numbers less than or equal to the number. What it means is that you first start writing the number and then count down until you reach the number 1. Now let's understand this with the help of an example. This is 4 factorial. So the value of 4 factorial is nothing but the product of all the positive numbers less than 4. So you have to first start writing the number 4 and then count down until you reach the number 1. So 4 factorial is equal to 4 multiplied by 3 multiplied by 2 multiplied by 1, which is nothing but 24. So 4 factorial is equal to 24. This is 7 factorial. So you have to start from 7 and count down till you reach the number 1. So 7 factorial is equal to 7 multiplied by 6 multiplied by 5 multiplied by 4 multiplied by 3 multiplied by 2 multiplied by 1, which is nothing but 5040. So 7 factorial is equal to 5040. 1 factorial is equal to 1. Similarly, n factorial is equal to n multiplied by n minus 1 multiplied by n minus 2 multiplied by n minus 3 and so on, multiplied by 3 multiplied by 2 multiplied by 1. As you can see here, each successive number is getting reduced by 1 till you reach the number 1. Factorial notation is useful when you are arranging objects. Now let's understand the concept of factorial notation with an example. There are 5 balls. Each ball has a number marked on it. There are also 5 boxes that you have to fill with these balls. How many different ways can you fill these boxes in? So you have 5 balls and you have 5 boxes, and you have to fill these 5 boxes with these 5 balls, which means each box should contain 1 ball. Now, the first box can be filled in 5 ways because there are 5 different balls to fill it with. So the first box can be filled in 5 ways because you have 5 balls and you have a choice of selecting 1 ball from these 5 balls. So the first box can be filled in 5 ways. Now, when you have to fill the second box, uh, since 1 ball is already in the first box, you are left with 4 balls. So you can fill the second balls in 4 ways because you have a choice of selecting 1 ball from only 4 balls. So you can fill the second box in 4 ways. Now the first box has 1 ball, the second box has 1 ball. So now you are left with 3 balls. So you can fill the third box in 3 ways because you have a choice of only 3 balls. Now the first box has 1 ball, second box has 1 ball, and the third box has 1 ball. Now you are left with only 2 balls. So the fourth box can be filled in 2 ways since you have a choice of only 2 balls, and so on. So what is the total number of ways you can arrange these 5 balls in the 5 boxes? This will be got from the fundamental principle of counting, that is the product rule. The first box can be filled in 5 ways, and the second box can be filled in 4 ways, and the third box can be filled in 3 ways, and the fourth box can be filled in 2 ways, and the fifth box can be filled in 1 way. So the total number of ways is 5 multiplied by 4 multiplied by 3 multiplied by 2 multiplied by 1, which is 120 ways. Now 5 multiplied by 4 multiplied by 3 multiplied by 2 multiplied by 1 is nothing but 5 factorial. As you can see here, you have started from 5 and then you have counting down until you reach the number 1. So the product of all these numbers is nothing but 5 factorial. So 5 multiplied by 4 multiplied by 3 multiplied by 2 multiplied by 1 is nothing but 5 factorial. Hope you have understood the concept of factorial because this is a very important concept while solving problems on permutation. Memorize the value of the following factorials, which will make it easier for you to solve the problems on permutations and combinations. 0 factorial is equal to 1. 1 factorial is equal to 1. 2 factorial is equal to 2. 3 factorial is equal to 6. 4 factorial is equal to 24. 5 factorial is equal to 120. 6 factorial is equal to 720. 7 factorial is equal to 5040. 8 factorial is equal to 40,320. Memorizing the value of these factorials will make it easier for you while solving the problems. Now, as you can see here, 1 factorial is also equal to 1 and 0 factorial is also equal to 1. Now, why is 0 factorial equal to 1? Now, factorial of n is nothing but n factorial, and the value of n factorial is equal to n multiplied by n minus 1 multiplied by n minus 2 multiplied by so on till you reach 1. Now, as you can see here, n minus 1 multiplied by n minus 2 multiplied by n minus 3 and so on till you reach 1 is nothing but n minus 1 factorial, because the numbers starting from n minus 1 is getting reduced by 1 till you reach the number 1. So this is nothing but n minus 1 factorial. So the value of n factorial can also be written in a partially extended form as n multiplied by n minus 1 factorial. N multiplied by n minus 1 factorial. So n factorial is equal to n multiplied by n minus 1 factorial. Now just consider the value of n as 1. Now you substituting the value of n as 1 in this equation, you get 1 factorial is equal to 1 factorial multiplied by 1 minus 1 factorial. Now 1 minus 1 is 0. So 1 factorial is equal to 1 factorial multiplied by 0 factorial. Now you know that in an equation, the left hand side, the value of the left hand side should be equal to the value of the right hand side. So this means that 1 factorial should be equal to 1 factorial. That is, the left hand side should be equal to the right hand side, and this can be possible only if 0 factorial is equal to 1. Now if 0 factorial is equal to 1, then 1 factorial multiplied by 1 is nothing but 1 factorial. So the value of the left hand side and the value of the right hand side in this equation will be equal. So as you can see, 0 factorial, the value of 0 factorial is 1. Now you have to remember that 1 factorial is equal to 1, 0 factorial is equal to 1, and n factorial is defined only for positive numbers. That is, factorials are defined only for positive numbers. Memorize the values of all these factorials. Let's now understand in detail about linear permutations. There are basically two types of linear permutations: permutations with repetition and permutations without repetition. Let's understand these two types of linear permutations. Permutations with repetition. In this type of permutation, repetition of objects is allowed. Now let's understand permutation with repetition with the help of an example. Supposing you have three letters A, B and C, and you have to make three-letter words from using these three letters. So let's find out how many words you can, how many three-letter words you can make using the letters A, B and C when repetition of the letters is allowed. So the first letter of the three-letter word can be any of these three letters A, B and C. So you have three choices here. So for the first letter, you have three choices. Now since repetition of objects is allowed, the second letter of the three-letter word can also be A, B or C. So for the second letter of the word also you have three choices because repetition of objects is allowed. Similarly, for the third letter of the word also you have three choices: A, B or C. So you have three choices for the third letter of the word also because repetition of the letters is allowed. So the number of different three-letter arrangements that can be made using the letters A, B and C is 3 multiplied by 3 multiplied by 3. that is 27. So you can make 27 arrangements out of these three letters A, B and C. You can make 27 three-letter words from the letters A, B and C if repetition of the letters is allowed. Now let's understand permutations without repetition. In this type of permutation, repetition of objects is not allowed. Let's understand this with the help of an example. Supposing you have three letters A, B and C, and you have to make three-letter words using these three letters. Now, here the first letter of the word can be either A, B or C. So you have three choices for the first letter of the word. But since here repetition of the letters is not allowed, and since one letter is already used uh, for the first letter of the word, you are left with only two choices for the second letter of the word. Similarly, you are left with only one choice for the third letter of the word because the repetition of letters is not allowed, and also because one letter is used for the first letter of the word and one letter is used for the second letter of the word, and hence you are left with only one letter for the third letter of the word. So the number of different three-letter arrangements that can be made using the letters A, B and C is 3 multiplied by 2 multiplied by 1, which is 6, when repetition of the letters is not allowed. So using A, B and C, you can make 6 different three-letter words when repetition of letters is not allowed. Hope you have understood the difference between permutations with repetition and permutation without repetition, and how to find the value when, for permutations with repetition, and how to find the values for permutations without repetition. Let's learn more about permutations with repetition. Let's suppose that there is a set of n distinct objects, out of which r objects have to be taken at a time. Now, when repetition of objects is allowed, at every step there are all the n choices available, since a choice can be made multiple times. So, when r objects have to be taken at a time, there are n choices available r times. Thus, there are n possibilities for the first choice, there are n possibilities for the second choice, there are n possibilities for the third choice, and so on till r times. Thus, the number of arrangements or permutations is equal to n multiplied by n multiplied by n multiplied so on till r times, which is nothing but n raised to the power r. Thus, the number of permutations of n distinct objects taken r at a time when repetition of objects is allowed any number of times is n raised to the power r. Now remember this formula as a repeating object raised to the power non-repeating object. Note here that n is the total number of objects. R is the number of objects to be taken at a time. Repetition is allowed and order matters. Now let's understand all this with the help of an example. Look at this example to understand clearly the concept of permutations with repetition. How many different car number plates are possible with 3 letters followed by 3 digits when repetition is allowed. So here the car number plates have to have 3 letters and 3 digits. Now since the car number plates should have 3 letters, let's have 3 vacant places like this. Now the first vacant place can be filled by any one of the 26 alphabets of the English language. So there are 26 ways of filling the first vacant place. Now since repetition is allowed, the second and third vacant places also can be filled by any one of the 26 alphabets. So there are 26 ways of filling the second vacant place and 26 ways of filling the third vacant place. Now, the arrangements for the 3 letters is equal to the number of ways of filling the first vacant place and the number of ways of filling the second vacant place and the number of ways of filling the third vacant place. Now, you know that and means multiplication. So, the arrangements for the 3 letters are 26 multiplied by 26 multiplied by 26, which is nothing but 26 raised to the power 3. Now you can find the 3 letters for the car number plates using the formula for permutations with repetition. Now the formula for permutation with repetition is n raised to the power r, where n is the total number of objects to choose from. Now here there are 26 alphabets of the English language to choose from. So here n is equal to 26 and R is the number of objects to be taken at a time. Now here since the car number plate should have 3 letters have to be taken at a time. So R is equal to 3. So here we have N is equal to 26 and R is equal to 3. So the arrangement for the 3 letters is n raised to the power r, which is nothing but 26 raised to the power 3. Now the car number plates should also have 3 digits. Now there are 10 digits, that is 0 to 9 to choose from. Now since the car plate should have 3 digits, let's have 3 vacant places. Now the first vacant place can be filled by any one of these 10 digits. So there are 10 ways of filling the first vacant place. Now since repetition is allowed, the second and third vacant places also can be filled by any one of these 10 digits. So there are 10 ways of filling the second vacant place and 10 ways of filling the third vacant place. Now the arrangement for the 3 digits is equal to the number of ways of filling the first vacant place and the number of ways of filling the second vacant place and the number of ways of filling the third vacant place. Now you know that and means multiplication. So the number of arrangements for the 3 digits is 10 multiplied by 10 multiplied by 10, which is nothing but 10 raised to the power 3. Now you can also find this number of arrangements for the 3 digits using the formula for permutations with repetition. The formula for permutations with repetition is n raised to the power r, where n is the number of objects to choose from. Now here there are 10 digits to choose from. So here n is equal to 10. R is the number of objects to be taken at a time. Here since a car number plate should have 3 digits, 3 digits have to be taken at a time. So here R is equal to 3. So N is equal to 10 and R is equal to 3. So the number of arrangements for the 3 digits is n raised to the power 3, which is nothing but 10 raised to the power 3. Now the car number plates should have 3 letters and 3 digits, and means multiplication. So the total number of arrangements is equal to 26 raised to the power 3 multiplied by 10 raised to the power 3. Let's now learn about permutations without repetition. Let's suppose that there is a set of n distinct objects out of which R objects have to be taken at a time. Now, when the repetition of objects is not allowed, an object cannot be chosen more than once. Hence, the choices after each event get reduced by 1. For example, for the first event, all the n choices are available. In the next event, however, there are n minus 1 objects available for choice since the object that has already been chosen in the first step cannot be included. Similarly, for the third step, we have n minus 2 objects available to us. Thus, the number of arrangements or permutations is equal to n multiplied by n minus 1 multiplied by n minus 2 multiplied by and so on till n minus r minus 1. Thus, when repetition is not allowed, the permutation formula for the number of permutations of n distinct objects taken r at a time is npr, which is equal to n factorial divided by n minus r factorial. Note that here n is the total number of objects to choose from, r is the number of objects to be taken at a time. There is no repetition of the objects and also the order matters. Now let's look at an example to understand the concept of permutations without repetition better. Now look at this example to understand the concept of permutations without repetition. How many 3-digit numbers can be formed by using the digits 1, 2, 3, 4, 5, 6 if repetition is not allowed? Now here you're given 6 digits. So the number of digits available is 6. Now, since 3-digit numbers have to be formed using these 6 digits, the hundreds place can be filled by any one of the 6 given digits. So, there are 6 ways of filling the hundreds place. Now, since repetition is not allowed and one digit is already used to fill the hundreds place, there are only 5 digits remaining now. So, there are 5 choices for the tens place. So the tens place can be filled in 5 ways. Similarly, since repetition is not allowed and one digit is already used to fill the hundreds place and one digit is already used to fill the tens place, now we are left with only 4 digits. So there are only 4 choices for the units place. So the units place can be filled in 4 ways. Now the number of 3-digit numbers is equal to the number of ways of filling the hundreds place and the number of ways of filling the tens place and the number of ways of filling the units place. Now and means multiplication. So number of 3-digit numbers is equal to 6 multiplied by 5 multiplied by 4, which is 120. Now you can find the 3-digit numbers formed by using the given digits by using the formula method. Now the formula for permutations without repetition is NPR is equal to n factorial divided by n minus r factorial, where n is the total number of objects to choose from. Here, since 6 digits are given, uh, n is equal to 6. R is the number of objects to be taken at a time. Now, since 3-digit numbers have to be formed, 3 digits have to be taken at a time. So R is equal to 3. So here N is equal to 6 and R is equal to 3. Substituting this in the formula, we get the number of 3-digit numbers as 6p3, which is 6 factorial divided by 6 minus 3 factorial, which is nothing but 6 factorial divided by 3 factorial. Now 6 factorial is 720 and 3 factorial is 6. So 720 divided by 6 is nothing but 120. Now there's a shortcut method to find the value of 6p3. Now starting with 6 in the descending order, there has to be a multiplication of 3 numbers. So 6 multiplied by 5 multiplied by 4, which is nothing but 120. Hope you have understood the concepts of permutations with repetition and permutations without repetition. Let's now learn a few special cases of permutations. The number of permutations of n dissimilar objects taken all at a time is given by n factorial. Let's find out how. Now we know the formula for permutation of n dissimilar objects taken r at a time is given by npr, and npr is equal to n factorial divided by n minus r factorial. But here the number of permutations of n dissimilar objects taken all at a time means n is equal to r. Now since n is equal to r, the permutation formula now becomes npn, and npn is nothing but n factorial divided by n minus n factorial. Now n minus n factorial is 0 factorial. So now we have n factorial divided by 0 factorial. Now since 0 factorial is nothing but 1, we have npn is equal to n factorial. So the number of permutations of n dissimilar objects taken all at a time is given by n factorial. Now let's understand this with the help of a few examples. The number of permutations of 4 distinct objects taken all at a time is given by 4p4. Now 4p4 is nothing but 4 factorial divided by 4 minus 4 factorial, which is nothing but 4 factorial. So 4p4 is nothing but 4 factorial. And 4 factorial is 4 multiplied by 3 multiplied by 2 multiplied by 1, which is 24. Let's look at another example. Using all the letters of the word Thursday, how many different words can be formed? So there are 8 letters in the word Thursday. So the total number of letters is 8. Now, using all these 8 letters, the number of 8-letter words that can be formed is given by 8 factorial. That is 8p8, which is nothing but 8 factorial. Now 8 factorial is 8 multiplied by 7 multiplied by 6 multiplied by 5 multiplied by 4 multiplied by 3 multiplied by 2 multiplied by 1, which is nothing but 40,320. So 40,320 different words can be formed using all the letters of the word Thursday. Thus, the number of permutations of n dissimilar objects taken all at a time is given by n factorial. Now let's understand one more special case in permutations. The number of permutations of n objects taken all at a time where A objects are of the same kind and rest are all different is equal to n factorial divided by A factorial. Now let's understand this with the help of an example. In how many ways can the letters of the word root be arranged? So in the word root, the total number of letters is 4. Now if all these four letters are taken at a time, then they can be arranged in 4 factorial ways. Also, the letters of the word root are not all different. You can see that there are two O's which are of the same kind, and these two O's can be arranged in 2 factorial ways. Observe here that n is the total number of objects, which is the total number of letters in the word root, which is 4, and a is the number of objects of the same kind. Here it is 2 since there are two O's. So the required number of ways is 4 factorial divided by 2 factorial. 4 factorial is 24 and 2 factorial is 2. So 24 divided by 2 is 12. So there are 12 ways in which the letters of the word root can be arranged. Let's now learn about another special case in permutations. The number of permutations of n objects taken all at a time, where A1 objects are alike of one kind, A2 objects are alike of second kind, A3 objects are alike of third kind, and so on, and AR objects are alike of the rth kind, and the rest, if any, are of different kind, is given by n factorial divided by a1 factorial multiplied by a2 factorial multiplied by a3 factorial and so on till ar factorial. Now let's understand this with the help of an example. Find the number of permutations of the letters of the word success. Now the word success contains 7 letters. So here n is 7, and these 7 letters taken all at a time can be arranged in 7 factorial ways. Also you can see that the letters of the word success are not all different. There are 3 S's and 2 C's. So here A1 is 3 and these 3 S's can be arranged in 3 factorial ways, and A2 is 2 and these 2 C's can be arranged in 2 factorial ways. So the required number of permutations is 7 factorial divided by 3 factorial multiplied by 2 factorial. Now 7 factorial is 5040, 3 factorial is 6 and 2 factorial is 2. So substituting these values in this fraction here and solving, we get 420. So the number of permutations of the letters of the word success is 420. Here is a quick recap of all the formulae to solve linear permutation problems. The number of permutations of n dissimilar objects taken are at a time when repetition of objects is allowed any number of times is n raised to the power r. The number of permutations of n dissimilar objects taken are at a time when repetition of objects is not allowed is npr. npr is equal to n factorial divided by n minus r factorial. The number of permutations of n dissimilar objects taken all at a time is n factorial, because npn is equal to n factorial divided by n minus n factorial. N minus n factorial is nothing but 0 factorial, and 0 factorial is equal to 1. So npn is equal to n factorial. The number of permutations of n objects taken all at a time, where A objects are of the same kind and rest are all different, is equal to n factorial divided by A factorial. You can remember this formula as overall factorial divided by repeat factorial. The number of permutations of n objects taken all at a time, where A1 objects are alike of one kind, A2 objects are alike of second kind, A3 objects are alike of third kind, and so on, and AR are alike of uh, the rth kind, and the rest, if any, are of different kinds, is n factorial divided by a1 factorial multiplied by a2 factorial multiplied by a3 factorial, and so on till ar factorial. Now you can remember this formula as overall factorial divided by product of the repeated factorials. Now observe here that the first two formulae are permutation formulae for n dissimilar objects taken r at a time. The next three formulae are the permutation formulae for n objects taken all at a time. Remember all these formulae, which will help you to solve linear permutation problems easily. Remember these points to solve permutation problems easily. If there are m things to be placed in one position, then number of ways is m. If there are m things to be placed in m positions, then number of ways is m factorial. Now, if a few things are of the same kind and the rest of the things are all different, then the repeat factorial or the product of the repeat factorials comes in the denominator. If there are m things to be placed in two positions, then number of ways is mp2. Now let's understand these points with the help of a few examples. Find the number of arrangements of the letters of the word independence. In how many of these arrangements do the words start with P? Do all the vowels always occur together? Do the vowels never occur together? Do the words begin with I and end in P? So here let's find the number of arrangements of the letters of the word independence. Now you know that the number of arrangements is equal to overall factorial divided by the product of the repeat factorials. Now here in the word independence there are 12 letters which can be arranged in 12 factorial ways. So the overall factorial is 12 factorial. Now in the word independence, n appears 3 times. So n can be arranged in 3 factorial ways. E appears 4 times, so E can be arranged in 4 factorial ways. And D appears 2 times, so D can be arranged in 2 factorial ways. And the rest are all different. So here the repeat factorials are 3 factorial, 4 factorial and 2 factorial. So the required number of arrangements is equal to 12 factorial divided by 3 factorial multiplied by 4 factorial multiplied by 2 factorial. On solving this, we get the required number of arrangements as 16,63,200. Now let's find out in how many of these arrangements do the words start with P. So you have 12 letters. So first mark 12 positions. Now we have to find in how many of these arrangements do the words start with P. So this means that you have to place P in the first position. Now after placing P in the first position, you are left with 11 positions for the remaining 11 letters. Now here you are asked to find in how many of these arrangements do the words start with P. So the required number of arrangements is equal to the number of arrangements in which P can be arranged in the first position and the number of ways in which the remaining 11 letters can be arranged in the remaining 11 positions. Remember that AND means multiplication. Now P can be arranged in the first position in one way. So 1 and is nothing but multiplication, and the 11 remaining letters can be arranged in the remaining 11 positions in overall factorial divided by the product of the repeat factorial ways. Now since we have 11 letters, the overall factorial is 11 factorial. Now the repeat factorials are 3 factorial because n appears 3 times, 4 factorial because e appears 4 times, and 2 factorial because d appears 2 times. So now we have the number of arrangements as 11 factorial divided by 3 factorial multiplied by 4 factorial multiplied by 2 factorial. Now on solving this, we get the number of arrangements in which the words start with P as 1,38,600. Now let's find out in how many of these arrangements do all the vowels always occur together. Now you know that there are 12 letters in the word independence. Now select all the vowels in the word independence and write the word as N, D, P, N, D, N, C, I, E, 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 E. As you can see here, you have selected all the vowels in the word independence and grouped them together into one group. Now, when the vowels I, E, 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 E have to always come together, they can be assumed as a single object. Now, this single object together with the 7 remaining objects or letters will be counted as 8 objects. So now you have to find the number of arrangements of these 8 objects. Now, the number of arrangements is overall factorial divided by the product of the repeat factorials. Now, since there are 8 objects here, the overall factorial is 8 factorial. Since n appears 3 times, n can be arranged in 3 factorial ways, and d appears 2 times, D can be arranged in 2 factorial ways. So here the repeat factorials are 3 factorial and 2 factorials. So the 8 letters can be arranged in 8 factorial divided by 3 factorial multiplied by 2 factorial ways. Now there's a shortcut method for solving this, for simplifying this fraction. To do that, first you have to find the highest factorial in the denominator. Here it is 3 factorial. Now you know that 3 factorial is nothing but 3 multiplied by 2 multiplied by 1. Now you can write 8 factorial as 8 multiplied by 7 multiplied by 6 multiplied by 5 multiplied by 4 multiplied by 3 factorial. Observe here that instead of writing 3 multiplied by 2 multiplied by 1, you have written it as 3 factorial so that you can cancel out these two 3 factorials. Now you know that 2 factorial is nothing but 2. So now you can easily simplify this fraction to get 3360. So 8 letters can be arranged in 3360 ways. Now you have selected all the vowels in the word independence and grouped them into a single group. Now all these five vowels need not be arranged in this same order. They can be arranged among themselves in different ways. Now, the number of ways in which these vowels can be arranged is equal to overall factorial divided by the repeat factorials. So, since there are five vowels here, the overall factorial is 5 factorial. Also, here E appears 4 times. So, the repeat factorial is 4 factorial. So, the vowels I, E can be arranged among themselves in 5 factorial divided by 4 factorial ways. Now 5 factorial can be written as 5 multiplied by 4 factorial. So after cancelling out these 4 factorials, we'll be left with 5. So the vowels can be arranged themselves amongst themselves in 5 ways. Now here you are asked to find in how many of these arrangements do all the vowels always occur together. So the required number of arrangements is equal to the number of arrangements in which the 8 letters can be arranged and the number of ways in which the vowels can be arranged. Remember that and means multiplication. So the required number of ways is equal to 3360 multiplied by 5, which is nothing but 16,800. Now let's find out in how many of these arrangements do all the vowels never occur together. Now, if we know the total number of arrangements of all the letters in the given word independence, and if we know the number of arrangements where all the vowels occur together, then the difference of these two will give us the number of arrangements where all the vowels never occur together. So the required number of arrangements where all the vowels never occur together is equal to the total number of arrangements minus the number of arrangements where all the vowels occur together. Now we have found out that the total number of arrangements is 16,63,200. And also we have found out that the number of arrangements where all the vowels occur together is 16,800. Now the difference of these two is 16,46,400. So the required number of arrangements where all the vowels never occur together is 16,46,400. Now let's find out in how many of these arrangements do the words begin with I and end in P. Now as you know, there are 12 letters in the word independence. So first mark 12 positions for 12 letters. Now we have to find the arrangements where the words begin with I and end in P. So you have to place I in the first position and P in the last position. And then you will be left with 10 positions for the remaining 10 letters. Now the number of arrangements where the word begins with I and ends in P is equal to the number of arrangements um, is equal to the number of arrangements of I in the first position and the number of arrangements of the 10 letters in the 10 positions and the number of arrangements of P in the last position. Now you know that and means multiplication. Now I can be arranged in the first position in one way. P can be arranged in the last position in one way. Now let's find out in how many ways the 10 letters can be arranged in the 10 positions. Now you know that the number of arrangements will is equal to overall factorial divided by the product of the repeat factorials. Now, since there are 10 remaining letters, the overall factorial is 10 factorial. The repeat factorials are 3 factorial because n appears 3 times, 4 factorial because e appears 4 times, and 2 factorial because d appears 2 times. So the number of arrangements uh, of the 10 letters in these 10 positions is 10 factorial divided by 3 factorial multiplied by 4 factorial multiplied by 2 factorial. So the number of arrangements where the words begin with I and end in P is equal to 1 multiplied by 10 factorial divided by 3 factorial multiplied by 4 factorial multiplied by 2 factorial multiplied by 1. On solving this, we get 12,600. So the required number of arrangements where the words begin with I and end in P is 12,600. Viewers, please go through this video till you have understood the concept. Please do watch all our videos on solved problems on linear permutations for better understanding. Please do watch our video on solved problems on linear permutations part 1. If you have liked this video, please like, subscribe and share this video. Thank you.